All right, we're finally diving into the book and getting going. So take out your notes packet. Make sure you get to the page that says 1-1. I think I often have mine labeled 0101. So it's the same thing. Title is variables and expressions. And we're ready to go. Are you ready? Hang on. I need a little coffee. Just what the doctor ordered. All right, here we go. Your learning target should start with the words I can all the time. So here we go. I can translate. What? Yes, translate. Basically, I want you to be able to translate now between words and algebra. So you are going to get, in today's assignment, you're going to get some math expressions, whether they're just numeric, actually they'll all be algebraic expressions, and you need to translate those and write them out in words. Excuse me. Or if I give you the words, I want you to be able to translate that into math. So it's kind of like understanding that algebra is like a foreign language. Math is a foreign language. I shouldn't say foreign, it's just different. And those symbols, when we read them, we speak the words, but the symbols are very powerful and speak another language, which, by the way, is often very universal. Okay? I can sit across the table from someone and we don't speak the same language, but we could do math together. Isn't that awesome? Wow. Here we go. First word, variable. All right. Well, I don't get super proper grammar-y when we're doing definitions. These are your notes, and I like to just put little chunks, little words that represent this, so I'm not so specific about writing a whole sentence. A variable is a letter, okay? And this letter happens to stand for or represent a value, and the big thing here is that this value changes. So it could be any letter of the alphabet, and it represents a letter or a value that changes. That's why we call it variable. So you think about something that varies, it fluctuates, it changes, variable. Oh, bingo. There you go. Okay, variable. Next is the word coefficient. Coefficient. What a great word. That's a cool word. I don't know that you'd hear it out of much other contexts with the exception of maybe some social studies or psychology when you're doing some statistical studies, but pretty much it's a mathy word. Here's what a coefficient is. Unlike a variable, a coefficient is a number. But specifically, it is a number that multiplies the variable. Multiplies the variable. Sorry, I'm kind of smushing that together. Trying to be neat, I swear. Okay, so it's a number and it multiplies the variable. Okay, next word, constant. Constant. My older sister constantly annoys me. What does that mean? All the time. A number that is constant is simply just the number. So in math, when we say constant, it's just a number, like 5 or 7 or 92, okay? -8.5. Okay, even though it has a fraction, it's still a number, it just doesn't change, okay? So we should say this as well. It's a number and it doesn't change value. I'm just gonna say doesn't change, okie dokie? All right, write down this expression somewhere near your vocabulary terms here, 2m plus 5. And when there's no operation written between the coefficient and the variable, it needs multiply, 2 times m plus 5. The 2 is the coefficient. So if you want to take a little arrow and say coefficient pointing toward the 2 in this case, the variable is the m. And this 5 is the constant. 5 is just 5. It's not changing. You know, whatever you get in the order of operations, when I give you a value to substitute for n, when you add 5, the 5 is always staying the same. So it's the constant. Two more terms. One is numerical expression. And when you look at this and you're thinking, oh, numerical, that means number. You're right. This is an expression that only has numbers and operations. Sometimes I like to illustrate our definition with examples. So we could have something like 3 to the second power minus 6, or 19 times 4 in parentheses plus 8 minus 4 to the second power or something. Just make a whole bunch of strings of numbers with operations. That's a numerical expression. What's a little different is something called the algebraic expression. And an algebraic expression, yes, it has numbers, yes, it has operations, but what makes it different is that this one has variables. Okay, so number, operations, and variables. So if we were going to think up an example here, let's pick like 18y minus 10, or x squared plus 1. Anything, as long as you see a variable in there along with the numbers and operations, that's what makes it algebraic. So you're going to hear me use this terminology a lot all the time, and that's what I'm talking about. Okay? All right, let's move on. Let's see if I can tap into some of your prior knowledge to see if you remember what some of these particular mathy words or words translate and how they translate into math. So let's look at this first one. The product of 12 and k. Product, product, product. Important word, means multiply. So we need to take 12 and multiply it by k. So you can write it this way. I'm going to caution you, now in the Algebra 1 book, you aren't going to see that traditional times symbol that looks like an X. We're not going to use that hardly at all for multiplication anymore. If I have an expression like this, you don't even have to put an operation between this number and the variable because multiplication is implied. But if it bugs you, you could put that raised dot, which also indicates multiplication, like that. The difference of y and 2, difference, key word there, difference, 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 difference. Difference means subtraction. Please be careful about the order. Y comes first, y goes in the front. 2. The difference of y and 2. Cool. Last one, quotient. Isn't that a great word? Quotient means divide. And again, order is critical when you're translating something that involves division. The quotient means dividing. K comes first and then 5. Or maybe you could write it as a fraction, k over 5, or k slash e bar 5, or old-fashioned long division way, k divided by 5, like that. Sweet. There you go. All right, that wasn't so bad. Oh, I have some tricky ones for you, though. And I have 2 of them, and I want you to jot these down. When I say tricky, let me explain why. The first one, more than. This would also be greater than 2. You can squeeze that in there. More than implies the operation of addition. Correct. When you are speaking it in words or you see it written, so if I say something like 7 more than h, okay? Yes, it means adding. And, technically adding can be done in either order, so that's okay. But really, when we read this, 7 more than h, 7 becomes the object. 7 is what's being added to something else. And so in theory, the 7 should get put in the back. Okay, 7 more than means I'm going to add 7. Add 7 to what? I'm going to add 7 to the h. That goes in the front. Oh, that looks backwards, doesn't it? Kinda. That's why it's a tricky one. Now, in theory, if you wrote 7 plus h, when you go to compute that, is that going to be any different? No, but really, whoopsies, really, we need to pay attention to the language, all right? So The reason why I want you to write that one that way is because of this guy. Boop, 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 boop. Man, if we could somehow put sound effects and blinking lights in your notes, this would be the place I'd want you to do it. Less than is the other tricky one. So, so here's what we have to look at here. Less than implies subtraction. And if I said something like 12 less than Q, then here's how you have to write it. 12 is what is being subtracted from the Q. So you have to put the Q first and then subtract the 12. And subtraction you definitely cannot do in the other order. On this one, it might even be good to write this. If you wrote 12 minus Q here and then put a big old nope, cross it out, you have to turn it around this way. Same thing if you look back at this one where it says the difference of y and 2. You could write 2 minus y there and then cross it out. Nope, that doesn't work. Doesn't work. You have to be super careful with anything that implies some division or subtraction because the order is very important. All right, let's look at some longer word phrases and see how you could translate these. The first one says, Sam types 45 words a minute. Write an expression for the number of minute or words Sam writes or types in M minutes. Okay, 45 words every minute, so 45 times M. And I'm just going to write it as 45M. 45 is the coefficient, M's a variable. Done. Sweet. Let's look at this one. Robert is 4 years older than Emily. Hey, take a second to think about that. Robert, Emily. Robert's older than Emily. So now, if I say, let's let that Emily's age be represented by the variable E, can you write an expression for Robert's age? Well, Robert is 4 years older than Emily. 4 more than plus 4. There you go. Okay. You should have a chart in your notes next. And I want to come up with some of these words that stand for these operations to get you tuned in and thinking this way. So if you just see that sign, you're probably thinking plus, add, or addition, or any form of that word. Blah, blah, blah. We just said more than or greater than, so that can go in there. Ooh, sum. That's a good math word, S-U-M. Here's one, total. That usually implies an entire list. Increase. That's a great word. You know, we're never going to get this complete because there's always some word I probably wouldn't think of. Here's a good start. We can always go back and add more later. The nice thing now, though, is that the next column is the inverse operation of this. So the word phrases will be antonyms or opposite words. So instead of plus, this in this column is minus. Subtract. Less than. Instead of sum, we would say difference. Instead of increase, decrease. I don't know if there's a good word pairing to be exactly the opposite meaning of total, but you could say something like take away or something like that. Okay? Sounds good. That's a pretty good list. Next column. If I just said read that, you'd probably say times or multiply or product. Those are all good ones. Sometimes you might, for a specific type of multiplying, if you ever see the word double, double stands for multiplying by 2, so that's kind of a specific multiplication one. You might have triple, quadruple, you know, you get the pattern there. Oh, groups of, that might be, you know, like 5 groups of 3 or something like that. So maybe that would be a word that would clue you in that we're talking about multiplying. All right. Times and multiply, now we come to its inverse operation. That would be divide. The word quotient is a great word, meaning division. Groups, maybe we could think of the word like separate or split, something like that. Okay? You get the general idea. Start thinking about these phrases and these words and what they imply from a mathematical standpoint. So let's look at a few of these, and can you come up with 2 ways to write this? In honesty, if you just read it first out loud, I would say F and divided by 3. I'm going to say you don't have to write THREE. You can use the number there, F divided by 3. I'm really after your verb and what's happening there. You could say the quotient of F and 3. Okay. There are a lot of other ones you could do. You could say F split into 3 equal groups, or F. I don't know. I think my brain's kind of toast right now. Those are at least 2 ways. Look at this one. If you simply read that algebraic expression out loud, you'd probably say y minus 9. Go ahead and write that. Other options, the difference, I'm forgetting the word the, difference between y and 9. You could say 9 subtracted from y. Y decreased by 9. 9 less than y. All of those work. You just simply have to come up with 2. Okay? Here's another one. X plus 12. First one's easy. Then you could say X increased by 12. The sum of X and 12. 12 more than X. 12 greater than X. The total of X and 12. Lots of possibilities. Use those words we've started to generate in your list. All right? Take a look at this one. It says the length of a rectangle is 6 units greater than its width. Okay, so first things first, I got to draw a picture, because the minute I see the word rectangle, that's what comes to my head. The length is longer, as 6 units longer or greater than the width. Write an expression for the length. Well, since we're coming up with the length in terms of the width relative to the width, we need to define what the width is going to be. So you need to pick a letter. Now listen, you can pick any letter you want, but I tend to go for the obvious answer. And the obvious answer to me is saying, let's let the width be W. Ooh. And that means that the width is going to be 6 more than W. So the length is W plus 6. Boom. Evaluate. Okay, so now you see BC. There's nothing in between. That's implying multiplication. Evaluate this expression, BC, for these values of B and C. B is 4. C is 2. It's implied multiplying. Boom. There you go. AB divided by C. Excuse me. A times B divided by C. Well, here's your order of operations being put to the test. Go left to right because there's no parentheses or exponents. 3 times 4 is 12. 12 divided by 2 is 6. Boom. All right, let's look at a few more. Oh, here's a good one. Brianna practices piano 30 minutes each day. Write an expression for the number of hours she practices in D days, and then find the number of hours she practices in 2, 4, and 10 days. Okay. Well, write down what you would write for this first expression. In a sense, it's almost like coming up with your formula, okay? Now, pause the video for a second, write it down. If you wrote this, you're wrong. What? Do you know why? Oh, mean. Isn't that mean? Absolutely. But you know what? They'll sometimes do this to you on a standardized test, and you need to be aware so you don't get tangled up in making a quick, speedy error when you should have noticed this. So 30 minutes. 30 minutes is what part of an hour? It's a half an hour. So really, we're going to take 0.5 times the days, or if you like fractions, you'd say 1/2 times the days. That's an expression to find out the number of hours. In part B, you have 3 answers because it's saying, first of all, if it's 2 days, then you have to take 1/2 times the 2 days. That's 1, and our answer is hours. If D is 4, that means you have to take 1/2 times 4, which is going to be 2 hours. And last but not least, if D is 10, then it's half of 10, which is exactly 5. There you go. Okay. Well, we're off. And actually, what I'm going to tell you to do is go ahead and check on Schoology for what your assignment is. Okay. Homework, check Schoology. It will be, part of it will be this workbook page, the first one, and then we'll continue on from there. So good luck, and may the force be with you.